Hi, my name is Zhen Fang. This is my demo reel including some projects made at LaSalle College Vancouver. Storm Engine is a custom game engine using C++ and DirectX 11. The renderer in the game engine can support different shader effects, including real-time lighting and shadows. Furthermore, extra details and realism can be achieved using multiple textures, including techniques such as specular mapping, normal mapping, and displacement mapping. The graphics system can also support multi-path rendering for post-processing effects, including blur, emboss, and glitch. 3D models and animations can be imported into the engine using a custom pipeline tool, which is based on the OpenSI import library. In addition, the engine can support basic physics simulation, which is based on valid particles with constraints. Using this feature, the engine can simulate class, solved body entities, and primitive collisions. One feature I spend the most time on the engine is the custom particle system. It is based on bright billboards and has many properties, which can be changed dynamically. This includes the emitter's position, particle velocity, start and end colors, and so on. To ensure the particle colors blend correctly, the particle system sorts all the particles based on the distance between their position relative to the camera's position. Finally, I added save load support so the particle system settings can be preserved for later use. For this, I made use of the InGUI file dialog extension to access the file system and the Rapid JSON library as a serialization format. Tyron is a 2D top-down tower defense shooter game created using Unity and C#. I've developed this project with 5 other programmers over a 12-month production period. I was in charge of 2 main systems, the tower system and the trap system. The tower system includes 5 different towers: normal tower, candle tower, chain tower, lightning tower, and town tower. I used the scriptable object to control the properties of each type of tower, including max health point, fire rate, and cooldown speed. I also used the Gizmos class to visualize tower attack ranges to help our designer decide the appropriate attack distance in the same window. To reduce the overload of our designer, I also used scriptable object for tower choice and the limit for each room in the level. The designer can easily choose which type of tower and how many towers can be set in the corresponding room. I used a similar method to build a trap system, including 3 different traps: clip, bomb, and black hole. In addition, I used the particle system to build a black hole visual effect and the enemy splatter effect, and I used the Unity shader graph to make an outline visual effect for the town tower and the streamer effect for the player. Overall, this project gave me hands-on development experience working with the Unity game engine and how to collaborate with the dev team. The water simulation project is developed using the Unreal Niagara system based on the smooth particle hydrodynamics method. The idea of SPH is to think of fluids as particles that interact with one another to form complex fluid motions. This method fits naturally with any particle system and is good at simulating fluid details and large deformation flows. One major problem with this method is that it is computationally expensive due to the requirement of neighboring particle search. However, the Niagara system offers a neighbor grid CD structure which uses a position-based hash lookup to optimize search time. I implemented a custom HISL shader to record neighbor particle information and used the SPH method to calculate the spatial density and pressure. Then I calculate the particle force in combination with other collision force. Using the force, I update the position and the velocity of the particle. In the future, I will complete the simulation by blurring the particles and adding appropriate materials to make them more like water. Thank you for watching. If you are interested to find out more about my projects, please contact me via my email.